animating characters is done through state machines and animation blueprints. Basically, state machines are mathematical abstraction where you have a finite set of states, and depending on which input you give it, it's gonna switch between states. So in our case, states contains animation. So you can have a state that has the movement animation, and the state that has the idle animation, and the state that has the attack animation, and so on. And whenever you want to switch between the states, you're gonna give them an input. In our case, it's gonna be Boolean. So for example, have a Boolean that we can set through the hero character here that says is moving, like you actually have it right here. And we can say whenever the is moving Boolean is true, then let's switch to the move state. And whenever we switch to the move state, the move animation is played. When the is moving is not true, we can switch back to the idle. So how do we use the state machines? We right click, and on Pixel 2D there's a sprite anim blueprint. Click it here, give it a name, hero character anim, it's a good one. Save it and double click it. And now you're gonna have the anim graph and just this. Now in order to make it work, we'll need a new state machine. So right click, new sprite state machine, right? So drag it here, compile, save. It's not connected to any state, it's gonna give you a warning, but that's fine. And now we double click, and we have the entry. So basically, you enter the state machine, and it doesn't contain any states. Let's add some states right now. So right click, add state, let's add the idle state, and right click, add state, let's add the movement state, right? So what do we want our state machine to do? So basically we want the idle state to be the default one, since basically whenever nothing happens you should be idle. So you have entry, and you're gonna drag and drop it into here, and you're gonna have a connecting arrow. So whenever we enter the state machine, the first state that we're gonna go to is idle. And now if we double click the idle state, you'll have the final Pixel 2D flipbook, and you have the asset browser right here. And you can just drag and drop an asset from here to here and link it. So in this case, the idle state contains the idle flipbook. Compile and save, and now we can go back by going from here to here. Right, and now for the movement, double click this, and let's find the movement state, shall we? We have the FB char run. This is good. Roll this, and now we have two states. Each has one animation, and they're ready to go. Now, how do we switch between states? For example, how do we go from idle to movement? Well, we just drag and drop from here, and now we'll be able to go from idle to movement by following the transition rule. The transition rule is most usually a Boolean that if it's true, it's gonna go into this state. If it's false, it's gonna go into this state. But as you can see, we only have a one-directional movement state transition. So for example, if we're in idle and the transition rule is correct and it transitions to movement, it cannot transition back to idle since we don't have any transition rules from movement to idle. So let's add one right now. You can add this just by doing here, this, right? So great, now we have transition rules. Now we double click the idle to movement, and you're gonna get this result, which is a Boolean. So let's make our own Boolean that's gonna handle transition from idle to movement and backward. And now in the variable section, we can just add a variable, and let's I usually preface the animation variables with an A so I know what they're about. And it's A is moving. That's a good one. Compile and save and drag and drop it. And basically if A is moving, then the rule applies and we can transition from the idle to the movement. Now from the movement to the idle, it should be the opposite. So if A is moving, and you can add the not boolean, so this just negates the boolean. So if the opposite of A is moving is true, then it's going to go back to the idle transition, right? Great. Now how do we actually set these? Like, we have the A is moving variable, but how do you actually make it true or false? Now, to do this, we now have to go back to our hero character. And first of all, let's link this state machine to this character. Linking is pretty easy. You just go to your pixel component, and down here somewhere you have the sprite anim instance. You click it and you just find your hero character anim. And it's done, you save it, compile it, and now you have it. So now these two are linked. Now basically you can use, this is gonna, every time this changes the state is going to be reflected on the animation that will appear in your character. If you don't link it, then doesn't matter what you do to the state or which state this is in, it's not gonna affect your character. Right, so now as you saw, in our movement node, we have something called is moving, right? Now, this basically spits out if the character is moving or not, which again we can do it manually by checking the axis value. So for example, you wanted to do it manually, you would see, is the axis value 0? If yes, then you're not moving. If no, then you're moving. Doesn't matter which direction. But for now, let's save this into a variable so we can reference it here. So to do that, just go to variables here, plus variable, and just is moving. So we don't have the A is moving since this is not the animation one, but you can add a B is moving, so you have the boolean indicator. I don't usually use it, but a lot of people do, so it's pretty good practice, I'd say. Now that you have the B is moving, you can drag and drop it, and you have get and set. Basically, get means gets the current value of the boolean, which currently is false since that's the default, and set, it sets the value of the boolean, and we want to set it, not get it. So you get this, connect it, and just drag it and drop it from here. So basically this means that whenever you move, since as you can see moving, the move right axis is triggered on each frame. So each frame, this move node is gonna spit out the is moving or not. So this boolean will always be up to date with your movement state. Great. And now, for example, how do we get this boolean here? That's a great question. Usually, blueprint communication is super important, and you will want to communicate between blueprints in a lot of different ways. But for now, let's go to your hero character anim state machine, and here, besides the new sprite state machine, you have the event graph. So basically, this is similar to this graph, but it runs on every frame, on every frame of animation. So each time the animation is updated. In order to try to get the functionality from the hero character to the animation blueprint, we're gonna use something called casting. Casting is a really important feature of Unreal, and it's something that you're gonna be using a lot. And basically says, if the object we're casting to is this object, for example, then we can have access to almost everything inside of it. So in this case, let's try to do that. Let's cast to hero character. So we have to cast a hero character, you have to cast a hero character class, but in our case we just want the actual object. And you have this here. And what's this? Basically, you add it takes an object, which can be any object, like you can just any object from your scene, and it checks if the object that you've added into it is an object of the hero character class, then you can get access to every functionality inside of it, the variables, the nodes and whatnot. You can get and set the variables, but if not, it's gonna fail and it's not gonna do anything, or you can make it do an error message. So in our case, which object do we want to cast it? That's a good question. Luckily, we have a functionality inside our animation blueprints called get pawn owner, and basically it tries to get the pawn owner of this animation blueprint. And since we actually added it here, then technically the pawn owner of the animation blueprint should be this guy, but you're not entirely sure until you cast to it. So basically try to get pawn owner, and you can add it here. And technically, if the pawn owner is the hero character class, which it should be, then it's gonna work. But what if for some reason it's not? It's important to have some backup in case something doesn't go right, and you don't want to get errors. So we can check if is valid. So basically this checks that if the object is valid, and if it is valid, then you can go and cast it, and if it's not valid, you can add a print and says object not valid. So basically this tells you something is wrong and you'll need to find out what. But again, this is just good practice. You don't need to add it, but I add it to most of my casting in order to be double sure there aren't any errors and whatnot. And now, since we cast it to the hero character, we can try to get the value of the isMoving variable. So you can drag from here, and you can just say isMoving, and you can have the get and set. So in our case, we just want to get it. Great, so now we have the isMoving. Right. And from here we want to take the value from isMoving and add it to isMoving, right? So you can drag it here and just set it. So take it from here and you set it. So basically each time the animation is updated, which is every frame more or less, I try to get the owner of the animation blueprints, which should be the hero character. I cast to it and I'm looking at its isMoving variable, and I'm taking the values from its moving variable and setting my animation isMoving variable to the same value of this one. So let's see if it actually works. Great, so as you can see, now we have the movement animation when you move, the idle animation when you're not moving, and so on. But I can think you can see there's something slightly off about this. It's basically the character rotation. So, and now you could add two different sprites, like sprites and flipbooks, depending on the direction. If you want your character to be moving in using a different animation for each direction, or maybe you only want them to move forwards, and if you move them backwards you have a slower like backstep animation. But in our case we don't want it, we just want to move backwards and forwards easily. Now this can be done super easily inside our hero character blueprint. We can go here and we have the input axis move right, and basically we know if they're moving in a direction, for example, if they're moving towards right, then the flipbook is correct. But if they're moving towards the left, we can rotate the flipbooks at 180 degrees. For this, we're gonna use a compare float node. Basically, what it does, it takes a float value, which is this one, and compares it to another value, and depending on the difference, you can make it do different stuff. So for example, compare float, you can add it here, and for the input we can add the axis value. In case you don't know what a float is, it's basically a numeric variable. You have a few numeric variables, but the most used ones are int, which stands for integer, and that's basically round numbers. So 0, 1, 2, 3, 4, 5, -1, -2, -5, and so on. And float is basically any number that has decimal. So 1.1, 1.2, -1.536, whatever. Those are floats. So there are other types of numbers, but we're not going to be getting into too much detail since I never used them for this project at least. But basically, if you want to make something with decimals and more fine tuning, you make it a float. If you want to have natural numbers, then you use an int as an integer. So to get back, now we take the value from the axis, which we know is between -1, 0, and 1, right? And we compare them to, in our case, 0. So if it's larger than 1, we want to set our controller rotation to 0, and if it's smaller than 1, we want to rotate it 180 degrees. So to do that, you find set control rotation, and if it doesn't appear again, just click on the context sensitive, and there you go. Right, and you want the same for if it's lower than 0, so you can just take this, copy, and paste it, right? So if it's higher than 0, we do it like this. If it's lower than 0, we do it like this. Great, and for the target, we can get controller, and we can link it like this. And since it's the same one for both of them, we can do it like this as well. And now let's add the new rotation. So we only want to rotate it on the Z, so we can drag and drop from here and check the context sensitive again, and you have the option to split this node into a rotator. So basically this is a rotator which has, as you can see, like degrees for X, Y, and Z. And in our case, we want to leave them as 0, since that's what we want. But in this case of, if it's lower, if the compare float is lower than 0, then we want to rotate it 180 degrees on the Z axis. So you just select this, copy by Ctrl C, paste by Ctrl V, and just drag the new value somewhere here. Okay. Again, how you organize your nodes is up to you. I prefer them to keep them similar like this, since they're a bit more compact. And as I said, on the Z you have 180 degrees. And now theoretically it should work. Let's test it out. So you have the pawn here, you move it like this, and oh, something went wrong. I know what went wrong, but let's try to debug it, shall we? In our case, what went wrong is something that you might find in other tutorials as well, but it's not explained, is basically the camera. So in this case, whenever we rotated the character, the camera rotated with it, so it had the same issue. So now you rated at 180 degrees, so did the camera, so that's why it jumps so severely. In order to fix this, we want the camera to be independent of the sprites or the controller's rotation. We want it to follow the movement but not the rotation. In order to do that, you can go to the spring arm component and just uncheck inherit pitch your roll, which is basically X, Y, and Z, or X, Z, and Y. I'm not sure exactly which is pitch, which is yaw, and which is roll right now. But if you uncheck all of them and use compile and save, now technically it should be working just fine. So as you can see, we move right, it's oriented right, we move left, it's oriented left. And now again, if you don't want to debug it anymore, you can just select these and delete them. Alright, so this is it for this part of the tutorial. Making a character is really complicated and a big task, and now we finished the movement part. In the next part we'll handle jumping and maybe even attacking. Hope you liked it, and don't forget to like and subscribe, and see you guys next time.